Hi everyone. We are still on parametric equations, but today we're going to look at solving parametric equations using trigonometric identities, the trig functions. We are given a problem that says find the Cartesian equation of the curve given by the following parametric equations. You have x equals to the sine of t minus 1 and y equals 5 the cosine of t plus 4, where t varies from 0 to 2 pi or 0 degrees to 360 degrees. So as we emphasized the last time, when you are given a parametric equations and you are asked to transform that equation into a Cartesian form, what do? You got to reduce the parameters. Cartesian here, you have x, you have t, you have y, you have t. So you have x 1, 2, y 3. So you have 3 different parameters here. We want to reduce them to 2. What we do in changing from parametric to Cartesian. If you're asked to convert from Cartesian to parametric, you add variables. The other way around, you reduce variables. So if that is the case, let's see what we can do here. And always is the parameter here that is given you want to get rid of. In this case, it's t. We don't want t. Cartesian coordinates, we use x and y. And we have parameter here t. So let's start with the first one here that says x equals 2 the sine of t minus 1. We want to make t the subject of the formula here. But looking at this problem, you are told that t varies from 0 to 2 pi. So let's see what it means. So now here you have x plus 1 equals to the sine of t. X plus 1 divided by 2 equals the sine of t. So you got this one here. Let's come to this side. You have y equals y minus 4 equals the cosine of t. 5 the cosine of t. So y minus 4 divided by 5 equals the cosine of t. But one thing we know for sure, that the sine of t, sine square t plus the cosine square of t is equals 1. Sine square p plus cos square p equals 1. Sine square k plus cos square k equals 1. If this is what we have, we know this already when we are doing trigonometric identities. Turn off the light. We know this already. This formula is very important. You should know it because you use it in most problems. And wherever you see any opportunity to use it because it always simplifies the problem. So if this is what we have, then, mind you, this corresponds to this limit. This works with this limit. This function now works with this limit. When it goes beyond this limit, it's something else. So now, if we square this, and we also square this, we know the sum of them is 1. So let's square now this. You have x plus 1. X plus 1 all over 2. We square everything. We know is equals to the sine square of t. And here again, if we square y minus 4 all over 5, we square everything. We know this is equals to the cosine square t. And so what do we have? Now we now see sine square t plus cos square t equals 1. So we now have, therefore, we now have x plus 1 all over 2 all squared plus y minus 4 all over 5 all squared, we know is equals to 1. We have this. We haven't proven this, but we know this is true. Right? So now let's make it look neat. Like this is not good looking. Let's make it look neat. How do we go about that? I want to remove these denominators from the parentheses. If you remove the denominator, this is going to be x plus 1 squared. This is now going to be 4. And this is going to be y minus 4 squared. This is now going to be 25. When it was inside the square, mind you, so outside the square is going to be 2 squared. 2 squared is 4. Going to be 5 squared. 5 squared is 24. 5. And all this is equals to 1. Find the LCM. You know what to do from there. So you now have x plus 1 squared you have 25 into x plus 1 squared plus 4 into y minus 4 squared. This is equals to 100. And all this is equals to 1. We just found the LCM. You know what we've done here. So it means this 100, we can make it as 25x plus 1 squared plus 4 into y minus 4 all squared. This is 100 is 10 raised to the power of 2. All this is equals to 1. So you can leave it this way: 25 into x plus 1 all squared plus 4 into 4 y minus 4 all squared equals 100. If you want to multiply this by 100, or if you want equals 10 squared, it's also accepted. Why I want to leave it 10 squared here? Because if you have, let me write it here. You know the equation of a circle centered in the origin is x squared plus y squared equals r squared. This is the equation of a circle centered in the origin. If it's not centered in the origin, then you have x plus h squared plus y plus k squared equals r squared. These are all equations of a circle. This one is centered in the origin. This one is centered somewhere around the origin. The value on the x-axis h and the value on the y-axis k. So you can see the similarities. This looks like a circle. Yeah? Problem solved. Thank you for watching. Bye bye.